Hello, Integrate. It's fantastic to be here. I love coming to this conference. I've been coming here for at least a decade, if not more, so I'm in a lot of those pictures you see, because you guys are such a great community to talk to and share our learnings with, and as well as our products and our futures. So I'm Kevin Lamb. I'm the, hello? There we go. I'll get back there. So I'm the Director of Product Management for Azure Messaging, which includes Service Bus, Event Hubs, Event Grid, Stream Analytics, Relay, as well as our streaming story that's in Fabric. So that's event streams and the connectors and that front door for Fabric streaming. And I'll be joined a little later on stage by Alicia. She's in my team running our event stream story in Fabric and ASA. Okay, so one of the challenges that we have today is that real-time data and AI are transforming the world that's around you at light speed. And that's a problem because we're used to working in different types of processes, and particularly in older systems where we were comfortable and complacent with batch processing systems and just hope batching got faster or we can schedule it more often. And so in the typical model, as you're doing the streaming, you'd go and observe, analyze, decide, and act, and this could take some time in a very latent kind of process. But today, as we're getting more and more of this data that's coming from everything that's around you, from cars to manufacturing devices to your applications, and we're being inundated by this data, and we have to react to that data. Being able to find that needle in the haystack is very challenging. And so there's a few challenges there in being able to go and acquire that data, being able to have the right type of systems to go and do the analysis in that data. And then, of course, it's fed in this loop because then as you're doing those analyses and ingestion, it's feeding back and then providing even more data into your observation models. And so one of the other challenges we have is that there are a lot of players out there that's in this space, but they concentrate on particular aspects. And they do some of those aspects pretty well, but they're kind of niche in their areas. So if you want to be able to do integration in the streaming space, you have to be experts in multiple of these technologies and bring it in. And you have to then have different licensing fees and ways that you go and deploy it and how these things integrate. And then you have to have specialists that come and then understand each of those components and then where that data lives. And so you have all these choices that you need to make in regards to which end of that pipeline you want to be at, as well as how if you want to be open source on-prem in the cloud, running your own systems, et cetera. And so that's a challenge, and we want to go and help address that challenge. And so we're moving from this fragmented, fragile tech stack to a single unified model. Right? It's an experience that you can come to one place and go and handle all that incoming streaming information. The advanced skill sets that you required for each of those particular stacks, and then needing those experts to come in and do that. And we want to democratize and have anybody in the organization go and do that acquisition and analytics on that data. We want to move from faster batch processing to real-time streaming data, right? So instead of having your systems run more frequently, we wanted to have it react as that data is coming in. As those events are being raised, we want to be able to ingest those and react to them. And data silos and lack of governance. You have all these systems and all the data is being stuck in those systems. Now you have to copy those and you're having multiple copies of all this data, and then you don't know where the source of truth is for that data. And so we want to create a unified data estate. And then finally, finding those unknown unknowns. And you have all this data in these disparate places. How do you go find out what is wrong? Right? Those unknown unknowns are really hard, and that's where we can get more AI powered to go help you find those anomalies and aspects that's lurking in your systems that you want to be able to take advantage of. How many people are familiar with Fabric? Oh, fantastic. That was a lot more than last time. So Fabric really tried to come and address the space by having a single unified platform that allowed you to have a single estate with one lake, and then having workloads that are built on top of that common model so that you have a single billing system, a consistent way of interacting with all these components. So we have Data Factory, and you can have your pipelines and data ingestion for your databases and batch processing, analytics with your data engineering, data warehouse, Spark workloads, databases. So we have SQL Server as part of Fabric, and just at Build, we introduced Cosmos DB as another database that you can have in Fabric. Real-time intelligence, which is what I'll focus on during this talk. And then, of course, Power BI, so you can have your visuals in your classic Power BI. Right, and that's all built on this common platform and a consistent way of interacting with all these components. So as we look at, particularly in real-time intelligence was built on the services that we've been running for a decade in Azure. So that includes Azure Event Hubs, Azure Event Grid, Stream Analytics, and Azure Data Explorer. We took those technologies that have been trusted and tested at enterprise scale and utilized those as the baseline for a lot of the components that we built in Fabric. We combine that with the self-service capabilities that you have with Power BI, an activator, including that single data state with OneLake, mixed it in with some AI, and then we have real-time intelligence. So the ability to go and really have that single place that you can go and do your streaming and analytics from. How many are familiar with real-time intelligence? Fewer, great. So you're at the right place. And so, as we look at those systems that we rely on, these are the systems that everybody in the world relies on. So we're doing 10 exabytes of data per month that's going through these event systems. We have 350 petabytes per day that's being ingested. We're running at over 5 nines reliable calls to these systems. So, this is planetary scale. That's really hard to do on your own, but we're here because, we're able to do that for you. And so as you look inside real-time intelligence has a number of components that it's made out of. So first is it needs to have event ingestion. So that's streaming and being able to have connectors that you can go and draw your streaming data from. Real-time analytics. So that's taking ADX and realizing that into the Fabric platform. Using real-time AI, so the agents and natural language processing that we leverage. Something that was introduced at Build is the digital twin builder as part of real-time intelligence. Real-time dashboards, so as that data is coming through, you want to be able to interactively work with the dashboard to go and analyze that data. Rules on top of that fast-moving data, and then actions that react to those rules as they fire. So I want to show a quick video to give you a sense of how all these parts can play together. Hopefully the sound works. Let's see.
Every organization faces challenges on responding quickly to changes in the business or external conditions like weather. Their success depends on how quickly and efficiently they can be proactive and adapt to these unexpected changes before they impact operations or customer experience. The real-time intelligence capabilities of Microsoft Fabric are a game changer for helping organizations integrate all of their data into an intelligent solution to help improve operations and mitigate disruptions before they occur. World-leading airlines like Contoso Air fly thousands of flights every week. They can have real-time data coming in from everywhere, including from Azure, Amazon, Google, Kafka, and even public data feeds. Today, I want to connect to our flight status data stream using Apache Kafka and bring it into the real-time hub. With just a couple of clicks, I can see the data flowing in. As the data is ingested, it can be transformed and routed to multiple destinations, or acted on immediately. This data is landing in Event House, which is specifically tailored to time-based, highly granular data. I can easily query petabytes of data on flight status, passengers, maintenance information, weather, and more, with answers to complex questions in seconds. I can also use Copilot to help me pull together separate feeds like flight and weather data. Fabric makes it easy to create interactive, operational dashboards so everyone can keep track of the data as it updates real-time. This opens up new opportunities for usage of the data by more personas within the organization. On our flight operations dashboard, I can easily track concerning flight patterns and set up alerts for excessive flight speed using Activator. It's seamless to drive action within Fabric, or in our operational systems using Power Automate. Prior to real-time intelligence, building a solution that ingests, monitors, analyzes, and more on streaming and high granularity data required deep expertise and complex tooling. Now, with real-time intelligence in Microsoft Fabric, we're democratizing the end-to-end experience for streaming and high granularity data, helping organizations succeed in the era of AI.
So one of the things that we found was really important is, especially in this world where we are talking about integration, right? So you do integration for a purpose. What are you going to do with that information when you integrate it? Of course, you have apps that you want to build, but you also want to be able to land that data into data stores and do analytics on it. And we want to make sure that's very easy to do, and you don't have to think of those things separately, but you can do it in one unified place. So as we look at, in that particular video, we were talking about airports. And as we look at the different industries that are out there and that have real-time scenarios, so we have airlines and manufacturing and energy and automotive and sales, and so all these are real in the sense that we even took some of the customers that we have and we aligned those with those industries. And so these are customers that are in these verticals or industries today that are using real-time intelligence. And so as we look at these customers, and we have more and more customers coming on board every day, I want to pick one particular customer to give you a sense of the value they get out of it. And so the one I'll pick is 1NZ. So this is a New Zealand Verizon, that'll be the next slide. So with all these customers coming on board, we're seeing that even though we only GA'd, became generally available with real-time intelligence back in November, we have over 9,000 customers using RTI with almost 300% year-over-year growth from when we started our public preview, as well as seeing that accelerated growth. So people are noticing that you can't live without real-time data. So now going to the particular customer. So 1NZ is the Verizon distributor in New Zealand, and they came to us because they were having challenges in their being able to service requests from their customers. And so there were the complaints they were getting is that they were waiting longer and longer on these phone calls, and they didn't have enough insight fast enough to understand how to manage those queues. And so they came to us and wanted to be able to get that streaming data that they were working on in Amazon and get it into Fabric so then they can do that faster real-time analysis. So we were able to stream that data through event streams connecting to Kinesis and getting that into an event house so they can do that alignment. And they went from customers and the queues waiting for minutes down to seconds. And so they really appreciated that, and it only took them 2 weeks to go develop that solution. So being able to move that data from their existing implementation in AWS to go and take advantage of Fabric, it was a very low cost in regards to development for them. And so they got great advantage out of that little bit of investment. Okay, so now as we look at what we have in real-time intelligence, I'm going to go to each of the components so you can understand how these components, what the responsibility for each of the components are. So here you see that there's a number of connectors. Those connectors get exposed to this real-time hub and all the streams. Then we have ingestion, analytics, the digital twins, dashboards, rules, and actions. And I'll go to each of those steps in the next coming slides. Okay, first is the real-time hub. So this is what we decided was the place to come to go and discover all of your streams. So one of the aspects that we wanted to make sure was really simple is that as people come up and create their streams, that they make it available for other users in the organization to go and consume those streams. And so one of the things that we found is as you're getting folks ingesting data into topics or into streams, that they were replicating those efforts. And so having all this in a single place in that hub, you can go discover those streams that are already ingested and utilize the streams that have already been processed and into the format that you need. Once you have those streams in, you, excuse me, you want to be able to explore that data. So you can go and interrogate the data, what's streaming in there. You can see the sample, the types of messages that are flowing through. You want to be able to go and connect to new pieces of data. So we made it super easy to go and connect to anything in your Microsoft estate. We first focus on your Azure components. So if you have Azure data streaming through an Azure component, for example, like a SQL CDC or an Event Hub, Event Grid, you're able to easily discover those and pull those in. But even if it's not in Microsoft, we have these connectors where you can go and connect to these systems. And so those connectors will go across cloud. In Microsoft, we have connectors for AWS, Kinesis, and Kafka, and other CDC sources, and I'll go to that in the next slide. And then you also want to be able to respond to things that are happening within the system. So we have Fabric events, right? That's built on top of our event grid. So just like in Azure, we have system events. We've created the same type of system for Fabric, so now you have these Fabric system events. I'll talk about that later as well. And then the new thing we introduced, we'll go deeper into, which is the event schema registry. So now you have metadata about the messages that are coming through your system. And so all this is available in the Real-Time Hub. You can kind of quickly access at your fingertips so you can understand that estate of your events and streaming in Fabric. So now as we look at ingestion and processing, and this is kind of the core of what we're going to talk about today. I'll talk about the whole thing in real-time intelligence, but this is really the core of being able to ingest these streams. So event streams allows you to connect to all these different sources of data. It's really the front door for streaming data that comes into Fabric. And we wanted to make sure that was very easy to go and utilize, and being able to do a get data and be able to select your source and then have that wizard go and create this event stream for you so you can go and access that data. We have numbers of connectors. So we have connectors for different databases for change data capture. We have message brokers, for example, like Service Bus and Solace PubSub. We have streaming connectors from third parties and open source, Kafka and Kinesis Streams and Confluent. And we have data feeds from like weather, et cetera. And you can see that we introduced recently some of these new ones. So MQTT, so you can connect to any MQT broker, like a Hive MQ broker. ADX CDC, so that's the Azure Data Explorer, and get changes from your Data Explorer. Weather data feeds, and you'll see some of that in the demo that we do later. And then Solace PubSub Plus. So we've been working with Solace to do that. And we have more connectors coming on all the time. One of the things that we're currently working on that's going to be released soon is being able to connect to sources that are behind VNets. And so the network secure items, and you can go and utilize connectors to connect to those items as well. With the event streams, we have a no-code experience to make it super easy to go and transform those streams into the format that you want. So that transformation includes filtering and managing the shapes of that data, so you can do this left to right type of transformation for those messages, as well as, because this is a streaming engine, we have aggregation. So you can do dupe detection over a certain window, or summations and averages, et cetera, in those in that stream, and then get that data landed into the particular destination or data store that you want. And so then as we go and push that data to the different destinations, for example, we can push into Lakehouse, and we go and handle transforming that data into either Iceberg or Delta format on your behalf, and you don't have to think about what those processes look like or write any code. Now, we realize that sometimes people it's like, I don't want to click 5,000 times to do something very simple, so we're introducing the SQL operator, where you can have a window that you can actually write your own SQL code that does the stream processing right in line in that code. Another important aspect is content-based routing. That content-based routing, you can interrogate the content of the body of the message, and based on that, on fields, you can determine where you want to send that to. So for example, if you have streaming data flowing through, and you want all of the cars to go into different databases based on the state, you can go and do that content-based routing and have them land in different tables or databases, or based on customer content. Okay, so that's event streams. So I'm going to take a moment and I'm going to ask you a question, which is, what are the streaming sources that you're interested in? So if you don't mind, you can go to this. The short one is aka.ms event stream sources, or take a picture of that QR code and upvote. Let's see if I can get this. Oh, that's not showing. That's okay. I was going to show you the live feed. That's okay. We'll go back. You voting? Yes? No? I'll give you another 30 seconds to go and vote. Okay, this is not showing my live voting window. That's okay, we'll move on. I want to make sure we give enough time for the fun demo that's going to happen later. Okay, so I'll go through these aspects a little faster. So one of the things that's really core to real-time intelligence is the event house in regards to being able to do this petabytes of analytics really fast on an engine that can go and handle that. So for high granularity time and space data streams, event house, which is based on Azure Data Explorer, is the way to go. This has practically infinite consumption volumes that you can do. It really gives you that interactive experience for being able to interrogate your data. So you're trying to do analysis and understand what's going on. Teams in Azure use ADX to understand what's happening within their services. So when an issue occurs, they can go and interrogate the petabytes of data that's coming in at that moment that there was an issue and find out what's going on. The indexing engine in the event house is so good that you can actually point this at your lakehouse or your OneLake data store and index that data so that you can get accelerated speed on your queries for utilizing it. So super powerful engine. This is a newly introduced at Build. So it's the digital twin builder. So this is your means by which you can go and get your physical assets and have a digital representation of that using an ontology, which is kind of your metadata for describing those components. So if you think about, on the manufacturing floor, you have a device, and those devices are built of components. Each of those components then they emit data from those components, and they'll have information about those components and how they relate to each other. And so we'll allow you to go, and we'll have a digital twin builder capability within RTI, so you can go and describe what those entities are, and now you see those relationships, and you can do that analysis of that data that's coming in. So as those events are being emitted live from those systems, right, that goes through an event stream and then lands, and then you can get to see that digital representation of that in the digital twin builder. Very exciting about this part. AI is everywhere, so I would be remiss if I didn't talk about AI. But we have AI, and there's going to be way more investments that you're seeing that's happening in AI and real-time intelligence. One is, as you're doing your analytics on your event house, the language that we use for the event house is KQL, the Kusto Query Language. And if you're not super familiar with it, and it's like, oh, I want to do this kind of more advanced query, you don't have to go and read up on it for 20 minutes or an hour to figure it out. You just type in natural language what you want, and it'll go construct that KQL for you so that you can go and extract the data that you want. But KQL is super intuitive, so just after a little while of using it, you'll understand why it's such a great language to go and do this kind of real-time analysis. You can go then, after you do that, you can go pin it to different, into Power BI or different dashboards, as well as being able to do analysis on your current custo tables, your event house tables, and then AI will go figure out what it is that you're trying to do with that data and then create these real-time dashboards for you. Super useful capability. And so we're going to see more agents and AI skills that are coming out of this based on the data that we have in Event House and going across your estate with different activities. The real-time dashboards is a great interactive way to go and see that data that's happening live, that's coming through your system. So you can have this operational view into your data, as well as share that data and have it pinned to other dashboards. And there's a no-code way of going and affecting those real-time dashboards so you can get it to be the shape that you want and in an interactive way. So as you're doing these interrogations, you're being able to use these graphs and dashboards to help you understand what's going on in your data. Activator is our rules engine for being able to write simple rules to go, and as the data is streaming through your system, based on these rules, we can go and monitor the data from different sources, either through an event stream. You can look at a Power BI report, look at dashboards, and then go monitor that for you based on these rules. And then from Activator can then automatically trigger either sending an email or a Teams message so that you can have somebody react to the rule that just fired. You can go and fire off different jobs, for example, running a notebook or talking to a pipeline, as well as being able to invoke a Power Automate workflow or a Logic App workflow. And then Fabric events. So this is the kind of system events that are coming through Fabric. And we've made this very simple to understand and utilize. So all these events are shown right into that real-time hub where you can go and simply right-click and subscribe to these events and react to those events as they're firing. So some of the events that we include is the workspace events. So that's essentially anything that gets added to a workspace or deleted. Job events, so your pipelines and notebooks and anything that executes and the status of those jobs. OneLake events, it's kind of like ADLS storage, but it's the OneLake that's in Fabric, as well as Azure Blob and ADLS events. We'll actually bring those events into Fabric so then you can react to them and then listen to changes in your data stores, in your Blob stores. And so, with real-time intelligence, we've, provided a platform so you can do your event-driven architecture. So, as you think about streams and events, you use these events to go and trigger your applications instead of relying on schedules and polling and aspects. So you want to be able to react to events. We've made it much more scalable. You can understand, the separation of producer and consumer. And so we're making it simple to understand and create these event-driven architectures, all based on the data that's coming through your system. And then you have event-driven observability. So observability with these events that occur, so you can go ahead and build your own monitoring on top of aspects that are running in your system. So you can watch pipelines. If your pipeline stops, you get to react to it and restart a pipeline or a notebook within Fabric. And customers we had like LSEG come and actually build one of these observability scenarios so they can manage their pipelines and ensure that it's always running. Okay. I want to step off the stage and give this off to Alicia, and she'll talk about some of the new things that are coming in Fabric.
Good afternoon, everyone. I'm Alicia. I'm the product manager in the Fabric real-time intelligence team. And on the Azure side, I'm managing the Azure Stream Analytics project. Okay, so this is my first time come to integrate. I see this conference is so focused and the audience are so knowledgeable. So I start to fall in love with this conference. I hope I can continue to come every single year. Okay, now in the next 10 minutes, I'm going to introduce several features we just launched or about to launch in the Fabric event stream. Let's get started. Okay, so the first one, SQL operator. So today that the customers can already using the no-code experience to drag and drop to express their business logics. And in this morning, that I think Markin has a very awesome session that he also demoed that how to use that capability. I think it's a good segue to this session. And now we see, we heard from the customer that, hey, this drag drop no-code experience is awesome, but we want more. So that's why we introduced the new SQL operator. So we are going to allow users to use the familiar SQL syntax to express your business logic, which is faster and more intuitive. And also, you can leverage the SQL operator to semantic to support more advanced scenarios. We also provided the accelerated integration with the building test and debugging capabilities to help to boost the productivity. We believe this is a big feature because this one that literally opens new doors for you so that you can build your advanced streaming analytics faster and easier. OK, now we come to the next one. So in the next two features, what we are going to talk about is about schema. Schema is the foundation of the integration. And it's a contract between different components. So it's super important. So imagine today that you are pulling the data from different sources, and they have slightly different schema. Today's event stream, it will give you outstream error, which we understand is very frustrating. And as we introduce this new feature, we call the multi-schema inferencing. It will automatically pick your source, sample your data, and then we are going to infer the schema of your data. After that, we are going to provide it for you so that you can do the downstream transformations. So now with this feature, we literally enable you can have multiple event tabs with a single event stream. And you can do the transformation with the diverse schemas. So instead of setting up a separate event stream for every single schema, now you can have all them together in one single event stream. So this is about we automatically inferencing your schema. So the next one is the event schema set. So there are places that customers like you want to manage your schema explicitly to get the better data quality or to do the metadata governance. So we heard that requirement, and we are going to launch this feature very soon for public preview. So right now, this is in the private preview. So we'll allow customers to define your schemas. You already know your schema, now you can define it. You can define it through UI, or you can upload your schema definition files. This will make, and we will put all the schema you define in a schema registry for make it easier for you to discover, manage, and reuse. This will help you to enhance the data quality so that you will know that once the data can successfully flow into your destination, they are already clean. So the data will be as expected. We provide the automatic versioning so that if even there's some schema evolution, that will be handled automatically. And this will help you to the granular access control. So no matter whether you are doing the real-time streaming pipeline or you just want to connect to the external data source, the schema registry will be your best friend to help you to make your world cleaner and easier. OK, our next one. The next two features we are going to introduce is about the two data sources we are adding to event stream. The first one is the Azure monitor their no-stick logs. So we will, on behalf of you, we are going to list the Azure resources that already have access to. And from there, with just several clicks, we can help you to route their no-stick logs into Fabric. So this including the VM metrics, the storage metrics and the logs, the metrics logs from the Key Vault, from the SQLDB, etc. So instead of having your Azure logs stay in our Azure and your Fabric logs stay in Fabric, now you can unify them all in one place. And another big value of this feature is that now you can correlate your telemetry with your business data. This will give you a lot of opportunity to enrich the data and to do more analysis to gain insights. So rather than just monitoring the metrics, now you can making more accurate decisions. And this feature right now is at private preview. So if you are interested in this feature, feel free to scan the left top one. You can take a picture, and feel free to sign up. And we are accepting the private preview customers. I'm sure many of you are dealing with error logs, so this one shouldn't be an unfamiliar one. OK, I'm coming to the last new feature we are about to launch. So this one is about Dataverse. So let me do a quick poll. How many of you have heard of Dataverse or dealing with Dataverse data? Wow, that's a lot. OK, thank you. So we are about to launch this feature to stream the Dataverse change events into Fabric with just a few clicks. Only 5 minutes left? No, it's wrong, right? No. OK, so in this one, so we are going to go to your environment, in your Dataverse environment, and then list the tables that you have access to. So this literally open up several new use cases, like the event-driven applications, anomaly detection, or just the incremental processing using either Spark or using KQL. So instead of processing the entire table, now you can just focus on what just happened. So this, let's take an example. Let's take example of the retail. In the retail store, let's say you have your product stock level. Now you are going to put that change event, sending that one into Fabric, so that it will help you automatically when the product stock level goes up or goes down because of the sales or because of restocking. Now you can use just that event to trigger the restocking automatically or to update the online store availability. So this solution gives you the low latency, I mean second, instead of minutes or hours. I'll give you the improved improved response. And also, it will allow you to act on the data while data is fresh, just created. OK, again, this feature is a private preview feature. And if you are interested in it, we haven't opened up the private preview yet. We are going to open it very soon. So if you are interested in this one, feel free to scan the barcode on the left corner. And yeah, you can take a picture, and you can give us the information later. OK. OK, now we come to the demo part. So just now we introduced the new features, new functionalities of event stream and the real-time intelligence. Now we are going to put them together to build something cool. So over the next 15 minutes, we are going to together build a smart building environment monitoring system. So we will get the signal from the temperature sensors, the power usage sensors, which are already in the MQTT broker, and we will use the temperature to monitor the temperature and trigger a team message alert if it goes beyond a certain threshold. We will correlate it with the weather data feed so that we know what's the weather going on right now. And we send the data into, we will monitor the temperature, power usage, and weather all in one single real-time dashboard. We will also, for the room, we will also have the second event stream to monitor room occupancy. So we start with a simple sensor, basic sensor. It only tells me whether this room is occupied or not. Then we will go to the second one, which will have the most sophisticated information of that sensor. We will demo that how event stream make this schema evolve easier. OK, now we can come to the next one. So our journey of this demo that starts from the real-time hub. So real-time hub is a single place where for you to discover, manage, and consume all your streaming assets in Fabric. It also give you easy access to the rich connectors. So in the connectors, as Kevin just introduced, that we have several categories. Start with the CDC. We have the CDC from the Azure SQLDB, MySQLDB, PostgreSQL, etc. The second category is the messenger brokers, including the event grid, namespace, MQTT, Google pops up, etc. The third category is the event brokers. For the event broker, we have the Azure Event Hub, Apache Kafka, Confluent Kafka, the Amazon MSK, etc. And also the last category is the Fabric events. So as Kevin just introduced, now you can act on the Fabric events on what's happening within your Fabric asset, like in the one lake to your jobs or to your workspace. And we also, later I'm going to also show you, we also have some public feed, which you can automatically get from those sources. Now in this one, we are going to use the MQTT. So first I need to set up a connection. Okay, we need your MQTT broker URL to set up this destination, this connection. After that, we need a topic name and the version. Now for this event stream, let's give a name. We call it the event stream, the room environment event stream. Now we can go to click the next. We quickly review the information. It looks good. Now let's start connection. Now in this step, it do two things. The first one is create an event stream and then add this MQTT as the source. Now when we open this event stream, the data already flowing in. We can see the building name, the floor, room, and timestamp, and also the temperature. Now we are going to do some transformations that we first use the filter. So in the filter that we are going to, so first give name to the filter, and then we'll take a quick look at the schema. The schema is already automatically inferred. It looks good. And we are going to select a column. Let's say we look at the sensor tab. We want the sensor tab equals temperature. So make sure we are managing data from the red sensor. Then we are going to click the manage field. And in the manage field, you can select the field that you're interested in. And also you can change the type or rename the columns that you need to help you to shape your data before we send it to destination. The first destination you want to send it to is the activator. In this activator that we'd like to monitor this information so that later we can act on it. Okay, click create. And then that we also add another destination as event house. Later we will build a dashboard we'll use to this. Okay, we give name to destination and select the event house. And we are going to create a new table for this one. Now let's publish this topology. After publishing that, we can click this activator and then open this activator. In the activator, we are going to define a new rule. The rule contains two parts. So one is the condition, one is what you are going to do, the action. So here for the condition, we will say, hey, when the select a column, the temperature, when the temperature is greater or equal to 80, they want to take actions. Activator provides multiple different options for you to take actions. And for the room or for the audience in this room, I think you might be interested in the logic apps. If you want to use logic apps, you just select that new custom action. It will give you a connection string. Then you can go to Azure logic apps and create a logic app with the activator as the trigger. Then use that connection string. And in this demo, just for the demo purposes, we are going to select the team message, so that when the temperature exceeds 80, I'm going to get a team message. And in the headline, I want to add more information, add a parameter in so I know which building, which floor, which room is getting this high temperature, and what the time it is right now, and what's the current temperature. After this configuration, I will save and start alert. So the start monitoring. Now we want to manually trigger alert. So I'm using this MQTT-X2. Let's update this to 81 degree, and let's send out this message manually. Yeah, you can see the 81 degree message got sent out. And immediately I can see my team message is flashing. So let's open this up, take a quick look. It tells me that the condition has the condition for this alert has been met, and give me the building name, floor, room name, timestamp, and the temperature. So the mission complete. So the alert is failed as expected. Now the next step that I have more data coming in. So I'm going to introduce the data status sending in is the power usage sensor. It's a new type of sensor. As the data arrive, that the multi-schema inferencing feature will automatically get the schema. So here I can see just not only have one schema, now I have two. Let me click that. Okay, we can see the power usage, the sensor type is a power usage, and it has a complete different schema compared to the previous temperature one. Now I'm going to do the similar transformation. I want to filter to the right sensor to make sure I'm getting the information from the right sensor, and it's a given name to the filter, and then validate the for the schema. I'm going to say, hey, only when the sensor type equals the power usage. Okay. And then for the manager, I'm going to add a manager field to do the same thing, to select the field that I'm only interested in. Okay, then after that, I'm going to send this data to another event house. So send this data to another event house and give a name to the destination, or to create a new table. Okay, now publish this one. Now we want to go to this event house. Let's see what is going there. Let's open this event house. Now we can see we have two tables here got created. One is for the power usage, and one is for the temperature readings. So the two sensor information automatically separated. Now I want to build a dashboard. There are multiple ways you can build dashboard. In this demo, I'm going to show you that I can leverage the feature in the real-time hub. I first find this temperature reading table, and then select this create real-time dashboard. It will leverage Copilot to automatically create a dashboard for me. You just click this one. Within 2 to 3 seconds, you will get a real-time dashboard. Okay, let's see what it gives to me out of box. It gives me the average temperature over time, give me the top 5 hottest room. But that's not too bad. I can directly use this one, or I can make some tunings. Customizations is better than me start from the blank page. Let's say I make some changes. Now I'm monitoring both the power usage and temperature. So since I'm already monitoring the temperature, I also want to know what the city weather at this moment. I want to correlate with the outdoor temperature. Now how to do that? We need to get the data from the public weather feed. So let's add that data into event stream. So we go to the edit view, and then we added the source. And here in the source, you can search because I have so many sources, and this keep growing. So you will need the search button. We search the weather data and first need to select a city. Let's select London. And then we give a name, London source, weather. Okay. Now this source is added. The public feed data is already flowing in. Now we want to do transformation. In this case, I'm going to use the SQL code I just introduced, and I'm sure you will love this one, that now you can write your code and give you a lot of flexibility. So we collect the source. And then we'll open the edit query button. You have a bigger window. Now you can write several lines of code, or you can run hundreds or thousands of lines of code. So it depends on how complex your business logic is. And here, just for the demo purposes, we just add a new column called location. And then we do the transformation of the temperature from Celsius to the Fahrenheit. Okay? Of course, you can do a lot of more complicated things than this. Okay, now we can publish this one. After publishing, we expect to see the weather data start to flow into a different table in Event House. Now let's open it. Now at real time, that the data arrived in the Event House, and we can see that after our SQL operator, the data is already arrived there. Now we can go back to the real-time dashboard. We can have the city name, we can have the weather information, and also the temperature. Okay, that's it for the first part of the demo. So in this demo, just a quick recap. We got 2 topics, one for temperature, one for the power usage from the MQTT source broker. And then we did some transformation. We triggered the activator alert. We send the data to the event house, and then we build the real-time dashboard. We also get the public weather data in, and using the SQL operator, did some transformation. And from there, from that, we also send the data to the event house. And within the new table, now we have the new source. We enriched our dashboard with the weather information. Okay, now we are going to move on to our second part. In the second part, we are going to have another event stream. So that event stream will give you will help me to track the room occupancy information. Okay, create a new event stream. And now I'm going to add a custom endpoint as my source. And here I'm going to activate this schema registry feature. Okay, let me add this one. And then, okay, now I want to associate this with a schema. So here you can define your schema, give a name to your schema, and give some descriptions so that later you will know what this one is for. And now you can add your schema line by line and tell me your type and the name of the row. Or you can also upload if you want to. Upload your schema file. And then we save this in a schema set, which is a collection of your schemas, helping to manage the granular level control. Okay, we just send this to the destination, to the event house. And before you send, you can validate which schema you want to use. And then here I also select that I want separate tables for each schema. Okay, publish. Now my client starts sending data to this custom endpoint. And here that you can select you need the SaaS key authentication. And here we also provide you the sample data so that it will guide you how to generate the cloud event and how to send the cloud event. And you can download this sample too. Okay, if you go to this event house, we see, hey, a new table got created called the room sensor occupancy 1. So this sensor tell me the basic room information, and it also give me the basic information of whether this is occupied or this room is not occupied. Okay, so as time goes, that the company purchased a new type of sensor, and the new sensor that it give me more information. It can tell me beyond this whether occupied or not. It can also tell me whether this is how many occupants are in the room, the count of the occupants. So all you need to do is just go to the schema you just edited, and here you can make some adjustment. We add one column that let's say called occupant count, and the count should be the type should be int. Okay, we saved this new schema. As you can see, that automatically saved as the version 2, V2 of your schema. The difference between V1 and V2 is V2 has this new count. Now the new sensor can start to send in the data. And if you go back to your event house, you will see a new table automatically got created called the room sensor occupancy V2. So even without touching your event stream, so this schema involvement already been taken care of. So you can see the occupant count is already here. Okay, I think that's the second part of the demo. So as you can see that this simple project, it touched multiple pieces from the MQTT broker to the event broker, the time series database, activator alert, the real-time dashboard. So it might take weeks to put them together, if no longer. But right now with the Fabric, we can get it done within hours. Okay, now let me get this back to Kevin.
That's fantastic. Thank you. And so, Alicia went and did this demo, but this is, real world stuff. We've been working with IWG, which is a company that leases out office spaces through Europe and around the world. And they were exactly looking for these types of scenarios to understand room occupancy and utilization of the facilities within those offices. And so this is not really made up. Okay, so one of the things I wanted to share with you in wrapping this up is our roadmap. So we have, you can see that we've been busy. We have a lot of things that we recently released, and then we have a roadmap. So I'll go and focus just on a couple of those items. And the roadmap, we talked about the event schema sets, and now we have a schema registry that's built in, and it will help you manage your schemas and schema evolution within Fabric Real-Time Intelligence. Azure SQL change event streams. So today we use Debezium to go and interrogate your change data feeds from lots of different databases. SQL is not very happy with the Debezium change data feed. It does real things to the database because it creates extra transaction logs and has overhead, et cetera. So what they did is they actually, instead of going and asking for that feed, now they're actually pushing it to an event hub. And so they're going to go and push it to an event stream as well because they're the same. And so we'll get that raw change feed from SQL being pushed into event streams. You can do that today with Azure SQL, going to a custom endpoint, and then later on we'll improve those experiences so you have single-click experiences to go connected to, but they're actually available today in Azure SQL. Microsoft sources, so we talked about Dataverse events, Azure Monitoring Real-Time Hub. We'll also add Microsoft 365 graph data, so then you can see things that are happening within, for example, your SharePoint or Outlook or AD. The connector on-prem or VNet connectivity, so if you have these sources behind firewalls, we get to go and access that data. Custom business events. So you saw about Fabric events, and Fabric events told you about the things that are happening within the system, and now you're going to be able to go and define your own business events that you can go and produce. So as a side effect of doing your processing and streaming, or one of these rules that are fired, then you can go and construct your own event that can then be fed into this loop, and things react to it, and then go and do analysis in that as well. Anomaly detection. So being able to use AI to figure out anomalies that you couldn't catch on your own. So as you're getting this high-speed data flowing through from your sources, being able to see these anomalies, these unknown unknowns, is going to be very, very easy to go and set up and create either out-of-the-box type of anomaly detection or using more advanced anomaly analysis. And then finally, Activator Fabric functions. So from Activator, I told you can invoke a pipeline or a notebook. We're going to add Fabric functions, which is essentially Azure functions that's now been embedded into Fabric, so you have this embedded experience. Okay, so that was a very, very fast kind of going through the releases and roadmap, and I wanted to thank you very much.